Alright, so we've got another rational function here, and we want to find a few things like the x-intercepts, the vertical asymptote, and the horizontal asymptote for this function. So the first thing you want to do is try to get this thing in factored form. So it's a quadratic. Negative means the signs are different, and two numbers that multiply to give you 8 but would combine or subtract to give you negative 2. 4 times 2 comes to mind, so 4 and 2. The 4 would get the negative. Okay, so 4 would get the negative because it's negative 2 here. And then x squared minus 9. So if we, that's a factoring this is the difference of two squares, so it'll be x plus 3 and x minus 3. 3 and 3 make negative 9, x and x makes x squared, 3x and 3x, negative 3x cancel, so there you go. So there's our factored form. To find the x-intercepts, you set the tops, you figure out where the numerator would give you 0. That's what you want to do for your x-intercepts. So x plus 2 equals 0, and x minus 4 equals 0. That's how you find the x-intercepts. So see, x equals negative 2, and x equals 4. So at negative 2 comma 0, and 4 comma 0 are the x-intercepts. It's easy enough. You set the top equal to 0. To find your vertical asymptotes, you set the bottom equal to 0. So I'll take my two factors here and set them equal to 0. So x equals negative 3, x equals 3. Those are my vertical asymptotes. And my horizontal asymptote, remember we check our degrees. The degree of the top and the bottom is the same. So you have a fraction of the front coefficient divided by the front coefficient. So y equals 1 over 1, which equals 1. So if I graph this, then let's see, negative 1. Here's my x-intercept. 1, 2, 3, 4. Here's another x-intercept. Those are going to be points. The vertical asymptote, I get a line going up and down at negative 3, and then at positive 3. And then your horizontal asymptote is going to go through 1. Sometimes you use solid lines. It just depends on what textbook you got and what they're asking for. That's how you find x-intercepts, your vertical asymptote, and horizontal asymptote of a rational function.